Installing combination arc fault circuit interrupter and ground fault circuit interrupter breakers on every branch circuit, beyond the obvious cost, presents several practical challenges. Firstly, space constraints can be a major factor. Arc fault circuit interrupters and ground fault circuit interrupters are physically larger than standard circuit breakers. This increased size means they require more space within the electrical panel. In situations where the electrical panel is small or already densely packed with existing wiring and breakers, accommodating arc fault circuit interrupters and ground fault circuit interrupters for every circuit may simply not be feasible without upgrading to a larger panel. Secondly, the cost is a significant consideration. Arc fault circuit interrupters and ground fault circuit interrupters are considerably more expensive than standard circuit breakers. Equipping every branch circuit with these combination breakers can substantially increase the overall cost of an electrical project, especially in homes with numerous circuits. Thirdly, system overload is a potential concern. Depending on the size of the home and the number of branch circuits it contains, installing arc fault circuit interrupters and ground fault circuit interrupters on each circuit could potentially exceed the electrical panel's total amperage capacity. This situation can lead to system overloads, causing breakers to trip frequently and disrupting power supply. It's crucial to assess the panel's capacity and the load requirements of each circuit before undertaking such an extensive upgrade. Fourthly, nuisance tripping can be a frustrating issue. Arc fault circuit interrupters and ground fault circuit interrupters are designed to be highly sensitive to electrical faults, which is their primary purpose. However, this sensitivity can also lead to them tripping unnecessarily, even in absence of a genuine electrical hazard. This is particularly common in the presence of certain electronic devices or appliances that generate electrical noise or harmonics. Nuisance tripping can be inconvenient and disruptive, leading to frequent power outages and the need to reset breakers. Fifthly, ground fault circuit interrupter protection is not universally required. Ground fault circuit interrupters are specifically mandated by electrical codes in areas where there is a higher risk of electrical shock, such as bathrooms, kitchens, outdoor outlets, and near swimming pools. Installing ground fault circuit interrupters on every branch circuit would extend this protection to areas where it is not strictly necessary, potentially adding unnecessary cost and complexity to the electrical system. Sixthly, compatibility issues can arise. Some arc fault circuit interrupters and ground fault circuit interrupters may not be fully compatible with certain types of wiring or appliances. This incompatibility can lead to problems with the electrical system, such as breakers failing to trip when they should or causing damage to sensitive electronic equipment. It's essential to ensure that the selected arc fault circuit interrupters and ground fault circuit interrupters are compatible with the existing wiring and appliances in the home. Seventhly, maintenance requirements should be considered. Arc fault circuit interrupters and ground fault circuit interrupters require periodic testing to ensure that they are functioning correctly. This testing typically involves using a test button and a breaker to simulate a fault and verify that the breaker trips as expected. While this testing is relatively simple, it does add an additional maintenance burden for homeowners who need to remember to perform these tests regularly. Eighthly, limited availability can be a factor. Combination arc fault circuit interrupters and ground fault circuit interrupters may not be readily available for all circuit amperages and types. This can make it difficult to complete a comprehensive upgrade, especially in older homes with less common circuit configurations. Sourcing the necessary breakers may require special orders or waiting for availability. Ninthly, the impact on insurance premiums may be minimal. While installing arc fault circuit interrupters and ground fault circuit interrupters can enhance electrical safety, it may not necessarily translate into a significant reduction in homeowners' insurance premiums. Insurance companies typically consider a range of factors when determining premiums, and the presence of arc fault circuit interrupters and ground fault circuit interrupters may not be a primary driver of cost savings. Homeowners should carefully weigh the cost of installation against any potential insurance benefits. Tenthly, future expansion may be limited. Installing arc fault circuit interrupters and ground fault circuit interrupters on every branch circuit can potentially limit the ability to add new circuits in the future. If the electrical panel is already close to its maximum capacity, adding more arc fault circuit interrupters and ground fault circuit interrupters may overload the panel or necessitate a costly panel upgrade. Careful planning is essential to ensure that the electrical system can accommodate future needs. In summary, while installing combination arc fault circuit interrupter and ground fault circuit interrupter breakers on every branch circuit offers enhanced electrical safety, it is important to carefully consider the potential drawbacks, including space constraints, cost, system overload, nuisance tripping, unnecessary protection, compatibility issues, maintenance requirements, limited availability, impact on insurance premiums, and limitations on future expansion. A thorough assessment of the electrical system and a careful evaluation of the benefits and costs are essential before proceeding with such an extensive upgrade. Arc fault circuit interrupters are designed to protect against fires caused by arc fault, which are dangerous electrical discharges that can occur when wires become damaged or insulation deteriorates. Ground fault circuit interrupters are designed to protect against electrical shock by detecting ground faults, which occur when electricity flows through an unintended path, such as a person's body. The combination of these two types of protection in a single breaker offers a comprehensive approach to electrical safety. However, it is important to understand the limitations of these devices and to ensure that they are properly installed and maintained. Electrical codes provide specific requirements for the installation of arc fault circuit interrupters and ground fault circuit interrupters, and it is essential to comply with these requirements to ensure the safety of the electrical system. It is also important to note that arc fault circuit interrupters and ground fault circuit interrupters are not a substitute for proper wiring practices and regular electrical inspections. These devices are designed to provide an additional layer of protection, but they cannot prevent all electrical hazards. Proper wiring, grounding, and insulation are essential for a safe and reliable electrical system. Additionally, regular electrical inspections can help to identify potential problems before they become serious hazards. In conclusion, installing combination arc fault circuit interrupter and ground fault circuit interrupter breakers on every branch circuit is a complex decision that requires careful consideration of various factors. While these devices offer enhanced electrical safety, they also present potential drawbacks that should be carefully evaluated. A thorough assessment of the electrical system, a careful evaluation of the benefits and costs, and compliance with electrical codes are essential for making an informed decision.